Hello everyone. Today I wanted to talk about voice recognition and voice command technologies and where they started, how far they've come, and why they still have such poor user experience. This is an area that has a lot of room left to grow, and I want to dig a little bit into that subjective element and some of the more objective reasons why I stand by that argument. But first I want to dig in a little bit into what is happening with voice technology. Across time, people have been envisioning different ways that they can speak to machines, objects, animals, things in nature, and have that thing recognize what is being said and react to it. So you have tons of examples from like the mirror in Snow White that speaks to the queen, to Jarvis, who is, like Iron Man's voice command assistant that helps him in battle. And there's a million examples of that because I think the idea of being able to say something or speak to something that is working for you and have it understand and do what you want is a really appealing thing on some primal level. Like, instead of having to treat something like a machine, we have to fidget with it, you can treat it as a person and have it help you. And since we as people are fundamentally very social creatures, there's something about that really resonates with us on some basic level, I think, which is why we keep coming back to this idea even before the technology to make something like this even possible existed. However, despite a lot of work being done in this area recently by tech giants like Google, Apple, Amazon, I don't think that technology ever quite made it to where they or the consumers wanted it to be. And I think there's a number of reasons for that. The way that a lot of these technologies have been implemented is through the use of digital assistants like Alexa, Siri, Cortana, Bixby. So that's been the main way that they've tried to kind of bootstrap that functionality. But so far, using a device with your hands, whether it's a phone, a tablet, a computer, or anything to that effect, has been pretty much the best way to get whatever it is that you're trying to get done using a virtual assistant accomplished. By the way, if this is your first time to my channel, then hello. My name is Kristina. I like talking about user experience, design, technology. I'm a product manager and have been working in the field for a number of years and love chatting about all of those different things. So hopefully you'll find this video helpful, and we'll get right into it. So let's start by talking a little bit about what speech recognition even is. We want to take that whole concept and break it down into three components because of how it's been implemented. So really you can do anything with speech recognition, but what has been done is part A, which is speech recognition, i.e. taking words spoken by a person and having them be interpreted into text by a computer. Part 2 is language interpretation, and what that really is taking the text that's been interpreted and making sense out of it, giving it context, meaning, and figuring out what somebody is trying to say with that language. And then part 3 is if the language is posing a question or giving some kind of instruction for the machine or computer to do something, actually executing that. So the best way to break down this understanding is recognition, i.e. hearing, understanding, and executing. And what we see as a more intuitive way of experiencing voice command is at this point the result of over 70 years of development. Speech is a very unique area that human beings are pretty uniquely adapted to do very well in. You kind of see different animals in the other parts of the animal kingdom be able to do things like African gray parrots can speak in the same way that people can, a limited number of phrases, I think it's something like 50, and apes can use sign language to communicate certain things. But even that is limited in how those animals can understand language. So for example, hypothetical queries or talking about something that hasn't happened yet is very difficult for them. And for speech recognition to be able to work, that has to be successful because those are some of the things that people talk about the most, is self-reference and hypothetical situations. What makes language specifically really unique and valuable and also very difficult to create is that it is a method of computation because it creates an infinite number of variables that can describe an infinite number of things. So other animals, most animals almost, can communicate using things like hormones, body language, and vocalizations. But those are limited because they cannot be used to create more variables to communicate more ideas than what is instinctually possible for that animal. So for example, if you have like a flock of birds, they might have a certain chirp that they use to signal for danger, but they aren't capable of creating a system of chirps to communicate something like a hawk is going to be coming at the end of the day, or there is a really good fruit tree over that hill. That is not possible. And so language can be also defined in those parameters as well. So why did we start trying to invent speech recognition in computing? Where did it start and where are we now? The progress of the technology can be looked at in 3 different segments. There is an earlier segment where speech was recognized and identified to specific templates that were created. So the researchers would create a certain template for a word like I or you, and the computer was trained to recognize that specific template. Next up, there was the second phase of statistics, where researchers used statistical models to figure out what is the likelihood of a certain word being used, and training the computer to interpret a word based on that likelihood. And we are now in our current phase, which uses deep neural networks, giant data sets, and cloud-based servers to train AI type model to understand what is being said based on an ever-evolving data set that also self-updates the model that is interpreting that information as well. The first era of this first phase that was based on templates starts in the 1950s. The Audrey device was created in Bell Laboratories, and it was able to recognize the numbers 0 through 10 only if spoken by its inventors, because they were the ones that they based their template off of. And it did so with a 90% accuracy, which was pretty good for a first pass, but that was the first iteration of voice recognition. And then in the 1960s, IBM did something very similar with its own device called the shoebox, basically a lot of different places were developing something along those lines at the time. There were research labs in the US, Canada, Japan that were all working on this in parallel. Words like Audrey and shoebox make you think of like something small, when in reality these were huge computer arrays that had hundreds of wires, took up a whole room, were not portable or cost effective in any way, and were really very rudimentary prototypes. As we enter the 70s, the US Defense Agency, DARPA, started funding a number of research efforts to try to get to 1,000 words being recognized 5 years after the start of its project. So it funded a bunch of different research labs to try to get to those 1,000 words. It started in 1971, and then it succeeded by 1976. So those systems are called the Hearsay 1, the Hearsay 2, Dragon, and Harpy. The Hearsay 1 was able to take a limited number of words and interpret them. It had a limited vocabulary, and it used templates to match those words with what was being said. It could process general speech, not only narrow task-specific words, which was a breakthrough at the time. And it could also transcribe the speech it heard as text, which makes sense because the machine has to take what it's being said and transcribe it to text in order to interpret it in the first place. They cannot process text as a sound wave. The Hearsay 2 model then did something similar, but it started working on a Blackboard platform where essentially the problem of the speech interpretation was being worked on in parallel by a number of parallel models, and they were all trying out different things to figure out if they could interpret the text at the same time, which made the model more efficient. Next up we have Dragon, and Dragon was very successful. It allowed for the application of models instead of rule-based approaches to understand what the text is, and it increased significantly the vocabulary range of what speech interpretation technology was able to do at the time. And lastly, we have the Harpy. So it used a technology called a beam search in order to go down a branching path of different possibilities in order to see what language interpretation is most accurate, and then pick the ones that are successful and discard the rest. So doing that, it was able to achieve DARPA's goal of getting to 1,000 words of recognition. So if you can imagine kind of like a branching tree structure, if the first letter is I, it's going to go down the path of a couple of different options like I am, I are. I are is grammatically incorrect, so it's going to discard that, go down I am, and then another possibility is very or berry. Berry makes no sense, it's going to discard berry and stick with very, and so on and so forth. So it does that very quickly in a branch algorithm and is able to find the word successfully that way. So Heartbeat does its victory lab and we enter the 80s. And that is when we moved from the rule-based approach to the statistical model approach, where the technologies that are being applied are using statistics to figure out the probability of something being correct and using that to make a best guess at what is being said. Kai-Fu Lee developed the Sphinx system in 1987, continuing the rich tradition of naming these systems after mythological creatures, which I think is actually really fun. As we enter the 2000s, we get to the neural network era. And at this point, DNNs are the most widely used approach for speech recognition. By 2017, DNNs had reached human-level performance at about a 5% error rate, and by the 2010s, a series of voice-enabled applications and devices saturated the market. So you'll be familiar with those. Those are things like Alexa, Cortana, Siri, all these different voice assistants that are meant for the consumer to use. At this point, speech recognition is best suited to working within a specific domain where it really knows specifically what is being asked of it. So for example, if it's being asked to work on a specific task that's maybe related to something like cooking or navigating, then it's going to know to hone in on words that are related to that field and perform really well. And today's portable devices are learning all the time. The things that we are saying to them is being fed back to the cloud, to the databases of the companies and agencies providing the service, where everything we're saying and whether the task is perceived as successful or not that's being executed as a result of what we said is fed back to help the algorithms that are powering these devices learn how to improve. And as we're using more words are being fed into the data set. Similarly, different voice types and accents and vocabularies, pitches of voice, tones of voice, all of those are being interpreted as well, as they are a very complicated type of data that goes beyond just the words being said, but how speech is created. That is one big limitation and difficulty actually of speech to computer translation, is that speech is analog and widely varies. You know, as a species, we've spent most of our evolutionary life cycle evolving to optimize ourselves for interpreting it, and as you may have seen in your daily lives, some things that are said are difficult to interpret even now after we've spend so much time optimizing ourselves for it. So overall, at this point in the 2010s, the real watershed moment for the technology that made it available to consumers is Siri, because Siri was able to take very open-ended questions. It was able to interpret an infinite array of vocabulary terms, seemingly. And very importantly, it was able to take things that you asked of it and apply those to auxiliary functions. So it didn't necessarily just, answer a question that you were asking of it. It could also do tasks like open your calendar, go to a certain day and create an event and name it so-and-so, go to your contact, create a new contact, or update an existing one with so-and-so number, things like that. And that made it very functional. And also it came free with your iPhone, provided you had one, so anyone who was using those devices had access to that. And so because you didn't have to go and buy it as a separate product, it was something you could try out and see if you liked it and make use of immediately. So we're talking a lot about the development of this technology and how it progressed and when it became a little bit more mainstream, but what is the point of speech recognition and voice command technology? The goal for creating it and optimizing it varied. So back when the research first started in the 50s and 60s, the goal was to make the translation of voice data more efficient. It was developed to reduce bandwidth, i.e. to reduce the volume of data traveling over physical wires. So the idea was that if you could take language, transcribe it into text, and send that as digital text, that would take less bandwidth than it would take to send over voice waves, which contain more data. That wasn't necessarily successful at the time. And as telephone switches became digital in the 70s and 80s, they enabled faster and cheaper call routing, so that goal didn't necessarily become relevant anymore. So with the bottleneck of bandwidth solved as a problem, the main value that's added now through speech recognition is to allow consumers, whether that's in the private sector, the public sector, in your personal life, in your work life, to interface with computers and machines in a way that isn't currently possible. In much of the same way that touch screens, screenless technology that doesn't exist yet, and neural links all hypothetically could allow you to do as well. So this is just another way of moving us away from using a mouse and a keyboard to try to do something new, something that's a little bit more suited for how we as people want to try to communicate intuitively. So have we succeeded at that? Well, if you look at the numbers, Google was in 2017 reporting that around 20% of its searches were done through voice. And it was predicting that by 2023, that number would climb from 20% to 50%. We are now in 2023, and that number is actually 27%. So the rate of adoption of speech recognition and voice commands is very, very slow, way behind what Google predicted at the time. And I think there's a good reason for that. Let's talk about why that is. If we look at this from a user experience lens, we need to talk about what makes a technology valuable and useful, and why would somebody want to use it, right? So the criteria that I want to talk about are threefold. One is how understandable something is, or intuitive, how valuable something is, and how universal and user-centric something is. So essentially, like, the way that we can talk about those three things are, is something intuitive, like when you look at something, is your immediate instinct for what you want to do the correct one that's going to get you the result you want? For value, is it doing something for you? Is it fulfilling a need that you didn't have fulfilled, and now that's filling that need? And for universality, it's a question of like, hey, if you're having a good day or a bad day, if you're using this versus your relative versus someone from another country, if you're using this while you're sick or you're healthy or stressed or injured, is this technology going to work for you under all of those circumstances, or is it relying on you to be a certain type of person? Otherwise, it'll fail you in some way. Yeah, so let's start talking about whether something's understandable or intuitive. When you speak to a machine, you end up lost somewhere between where you would be if you entered a text-based query into a machine, into something like, let's say you're using Google as a search engine, you type in a question, or you type in a little fragment like best places to vacation in summer or whatever. You end up between that and where you would be if you talk to a person and ask them something. They might not have, total knowledge of everything the way that Google does, but it's a person who can understand what you're saying and pick up on context and what your voice is trying to do. So you end up somewhere in between, where you don't get the precision and the visual feedback and all of that you get from the search, and you don't also get the human soft ability of a person understanding and picking up on things you're not saying but secretly want. You're somewhere in between. And again, with a query, you can get a ton of data back, and with a conversation with a person, you can have them self-direct. You can be vague in what it is that you're trying to say and have them pick up on unspoken things, contextual cues, things like that, and even have them ask follow-up questions as needed as they're trying to understand something. And then they go and do their thing, and because you trust them, presumably, to complete that task, they are able to be successful by doing it how they would do it. So yeah, with voice commands, you're kind of in between those two states. You can't use things like markups in your query, like for example, when you can want something to be an exact match. So you can't do that, and you can't also be vague. You have to work within the limitations of what the machine can understand and interpret. And because you're being encouraged to speak to it like a person, you don't really know where those limits are. So you start from the assumption of it can understand everything, and if it fails, you have to kind of work yourself back until the point of where it understands. And who really wants to sit and do that over and over again, right? Because those limits are going to vary depending on what you ask. Like, for example, let's say you're trying to find out where a city is located. Maybe you mispronounce the city a little bit and you fail to do that the first time, and then the second time around it asks you, did you mean so-and-so? And you acknowledge it and it gives you that city. So that means you managed to complete that task in 2 steps. Let's say you're trying to do something else, like ask an ambiguous question, like what is the best way to apply for a job in 2023? And it gives you 3 or 4 incorrect answers. You kind of figured out how to do 2 separate things, but because the problems you are running into are typically different for those 2 things, one is pronunciation, the other is vagueness, you can't take what you learned from one task and apply it to the other. So you keep having to relearn how to talk to the machine over and over again, which is frustrating for someone who's trying to get something done quickly. The whole point of speech recognition is that you can take something that takes a longer time to type in or something like that and do it faster than you normally would. So unless you can do that, unless it can be faster than pulling out a phone and typing something in, then nobody's going to use it. So another thing that is a little bit tricky is that assistants sometimes try to suggest things that they can do. Like, for example, when you open up Siri, she says, ask me a question, tell me to say a joke, ask me what a good cookie recipe is. And that's great, but those categories are hard to remember, right? And they often also rely on the use of an auxiliary app. So for example, if you want to place an order on Amazon using an assistant, then you have to have the Amazon app installed on that same device so that the assistant can integrate with that app, place the order for you, and confirm. If you don't have an app for that, or there's no integration, if normally you would go to Amazon in the browser of your phone to place an order or on your computer, then you're not able to complete that. So you basically have to have an app for everything. Or if you don't love having an app for every single little thing, you're going to give the command to the digital assistant and they're going to try to execute, and they may or may not succeed. And unless you have your list of apps memorized, which most people probably don't, right? You're not going to know when it's going to succeed or fail. So it's like a 50-50 chance, or it's not literally that, but that's what it's going to feel like, of whether it's going to succeed or not, based on whether you have the correct integration. In fact, Amazon was using the Echo device, which is able to, take voice commands when prompted to start listing, interpreting things. It was using the Echo Dot as a loss leader in the hopes that by having it sit there in the middle of a home, people would start talking to it, ask it to place certain orders, like, oh man, I ran out of sugar. Hey Alexa, in the Echo Dot where you live in your palace of foam, please place an order for salt or flour or whatever it is that I'm out of. But the thing is, that's not how people shop, right? So even for something like groceries, the way that Amazon is set up, your groceries have to be a certain amount of things to reach, like, I think it's something like a $35 limit before they'll send out the groceries. So you can't just say, hey, bring me more flour. You have to start talking to the Echo and enumerate like a bunch of groceries to get to that $35. And I haven't tested this myself. I don't have an Echo Dot, but I suspect it's not going to tell you like you are $8 short of your $35 goal to qualify for Amazon groceries. So that's like a no-go, right? And then if you sit down and think about the way that you last bought something, you probably aren't anywhere close to just sending a 1-sentence prompt to buy something and have that be acknowledged. Typically when people buy things, they like to comparison shop, they like to, and especially online, they like to look at photos of things, they like to read reviews, like is this a 4-star? What's the photo of this thing in the context of the space where I'm going to put it? You scroll down and look at other suggested items that are maybe similar, something catches your eye, you have 5-6 tabs open and you kind of look through the different options. This sounds like a lot of tasks, but we're really good at doing them. So we're knocking those things out very quickly, and even if you're buying something simple like a USB cable, you can have that done in 2 to 3 minutes and be happy with your choice because you looked at the price, you looked at a couple of different options, you saw that there were good reviews, you saw that it qualifies for maybe something like free shipping, and you were able to place your order. That's not possible with voice commands. If you tell Alexa to buy a USB cable, you don't know what's going to show up. Like, presumably it'll be fine, but a lot of people want to have a little bit of control over spending their money because most people don't have a ton of money to burn on making unwise purchase decisions. So where does voice recognition deliver value? I'm done roasting it for now. Let's talk a little bit about where it does well. I would say there's two areas that it's really useful in. So I think the best application is for an instance where somebody cannot use their hands, which is the main way that we have of interacting with electronics. And that includes situation like, for instance, cooking. Like, let's say you handled some raw meat, or you have flour and dough all over your hands and you're trying to follow a recipe online, or maybe you're watching something while you're baking, it's relaxing, or listening to something and you want to pause, you want to maybe scroll down and see what's further down on the page of the browser. I actually haven't found a great solution to the cooking component I'm just describing right now because, like, for example, I really like looking at recipes while I am cooking or baking. And the recipes are most often in the browser because I do a search for something very specific. Maybe, it's a foreign cuisine, maybe it's something specific, but I don't like using one app for recipes. I like searching through everything. And that means that the recipe is going to be in the browser. And voice commands are really bad, like I mentioned before, of working with browsers. So the very simple thing I need to do of scrolling down the page, or for example, for the page to quickly scroll past that big wall of text that you have that is a story about here is the tale of my grandma's recipe and its whole history. Oh, and by the way, here's the actual recipe. If I want to just tell us to scroll past the whole story and just get to the recipe, there's no real way of doing that. Also, I recently learned that the reason why they have that whole story at the beginning is for search engine optimization purposes. So you have to have a certain amount of text on a page for it to be recognized by Google as having valuable content. So if you just have the instructions, which is going to be 300 words, that's not considered good by Google. So you want to have the story in the beginning to create a little bit of incentive for Google to pick up the recipe. And having a lot of reviews saying that the recipe is great is not sufficient. So now I understand why we have novels at the beginning of those pages. So another situation that's also similar is driving. You don't want to use your hands because they're busy operating your car or your motorcycle, and you want to avoid looking at a screen or using your hands to operate it. So instead, because you can't look, you want to be able to give specific instructions to your phone or whatever device it is that you're using to navigate, like maybe it's a GPS or something. Those specific instructions can be something like finding the nearest gas station or playing a certain artist on something like Pandora or Spotify, which is well integrated with voice commands. I'd say that phones and the phone virtual assistants have been pretty good at working with map apps and music player apps. And they do a really good job of helping you navigate and to change your music. And they are solving an actual problem of addressing needs that come up related to those apps while you're driving. It's not trying to fix something that isn't broken. It's actually delivering a little bit of value there. So I would say that's one area where speech recognition is successful. I will also say there's a little bit of value delivered through the novelty of the technology. Like, it can be fun pulling up a voice assistant and messing with them and, asking them like what their hopes and dreams are and seeing what the voice assistant says. So that can be a potential area, but it hasn't really been explored. Like, for example, if you took that novelty of that technology and applied it to something like gaming or entertainment, that could be useful, but I don't know of any video games that use voice recognition technology, so that's maybe a missed opportunity. Famously, since its inception, and despite some steps that have been taken to ameliorate this a little bit, voice recognition technology is not good with diversity of speech. And that includes things like tone, pitch, accents, everything that has to do with the quality of a voice. And part of the issue is the data that's being used to train the models that are powering these systems. They are biased, right? And this isn't through any malevolent intent on the part of people. It's that people do feed biased data sets to machines. actively and passively, and we'll go over the difference there in a little bit. But basically, if you're going to have a bias in the data, you're going to have a bias in the functionality that comes out of being trained on that data. So for example, my mom uses voice commands on her GPS to try to navigate, and her voice is fairly high. The GPS is bad at recognizing high voices because there is a bias in data sets for lower voices. This is well known. And as the GPS doesn't recognize what she is saying, she gets frustrated and repeats herself. And as she gets frustrated, the emotion component that also the GPS doesn't account for makes her voice increase in pitch. So as she gets more irritated and is trying to repeat herself and her voice increases in pitch, that makes the GPS less and less likely to recognize what she is saying. So I have had to explain to her that she needs to pitch her voice lower in order to speak to the GPS, because that is how she's going to get herself understood and be able to complete the task she's trying to do, which is get from point A to point B. So aside from the gendered component of male versus female voices, there's a safety concern. Like, let's say you're a man and you bought a device that uses voice activated commands, and you're not gonna like flip genders overnight and have a high pitched voice, but you are able to be injured or have a medical or other type of emergency. Let's say you're having a stroke or a heart attack. When you have those incidents happen to you, stroke makes you slur your speech. Heart attacks mean that you're possibly gasping for air as you are experiencing that heart attack. And in the case of those types of medical emergencies, you're going to need a voice-activated device more than ever because you could be incapacitated. You might not have control of your hands in a stroke. You might be on the floor. If you have a heart attack, you can't get to your device. That is when you're going to need that voice-activated technology to call for help, call a loved one, call 911. That's when your technology fails you. That is like a major problem that should be addressed, because you are actually more used to that technology than you would have been otherwise if you never used it. You've grown to, be able to rely on it. And if you're trying to use it and it's failing you, you could have tried doing something else in the meantime that might have been more successful instead of relying on something that worked for you before but is failing you now. Similarly, I talked a little bit about emotion during things like trying to get the GPS to do what it is that you want to do. So if you're having an emergency at home, like there's violence or there's an accident, and you're trying to speak while being emotional, your voice is likely to be much louder or much more quiet. And that's going to distort speech in a way that data sets are not trained to interpret correctly, because the data that's being fed to these models rely on typical behavior. Typically, someone's not screaming in an accident or whispering because there's a home invader and they're trying to stay quiet. They apply to 99.9% of situations. So that 0.1% of the situation, there's data that's lacking there, that's not being accounted for, and is not being used to train the model. In addition to those components, we need to talk about the elderly and children. We talked about medical emergencies, and elderly people are more likely to experience those types of medical emergencies. Elderly people are more likely to have high, reedy, wavering voices with speech impediments if they're starting to lose their teeth or having some other issues. And that means that they are going to be less likely to be understood by a speech recognition device. And they are a demographic that's more likely to have some kind of medical emergency than average aged people. Actually, another thing that I thought of while I was putting together my thoughts around this whole topic for a video was a sector I never really thought about. So I was thinking about cars and how in order for voice activated technology to work well in cars, it has to be free of noise, and the person speaking has to have a standard non-regional accent. And who is it that drives all the time in noisy places, needs navigation to places that are unfamiliar, and has strong regional accents? It's taxi drivers. It's rideshare drivers. They're probably a major demographic of somebody who could benefit from voice recognition and speech recognition, and they're not well serviced by the fact that it can't handle accents when such a huge amount of people working in driving professionally are immigrants. Let's talk a little bit about the outlook of this technology. And I want to use the Gartner hype cycle as a bit of a model. This is a very not scientific cycle that's kind of like pop science to talk about the different areas of maturity that a technology goes through as it develops. So you kind of start off with nothing, and then there's a hype peak, and then it goes into my favorite part, the trough of disillusionment, which basically means that like everything that was promised from this technology didn't come to pass, and people are kind of bummed out by it, so a lot of people are dropping off. And then we reach the plateau of productivity, is what it would be called, where essentially technology has found its niche, it's matured, it's being used by the right people in the right places. Maybe not everyone's using it, but it's found kind of like a happy medium for itself, where it's going to be at a sustainable point between the high and the low. I guess my current assessment is that speech recognition in its current model, we talked about how, you know, it started out with templates, it moved into statistics, and now it's in the model phase where we're using certain types of learning to crack speech recognition. Unless there's another breakthrough, it seems like it's plateaued, because there were surges of a lot of improvement early on, but we've had diminishing returns since then. And unless we change how the data is gathered, how information's picked up, then we're not going to improve on the issues that I've outlined. You know, if you ask for something complicated in your shopping experience, you're not going to get that. You can't have speech recognition self-direct. You can't have it do something that requires visuals. You know, it's going to fail where a person doesn't. So a person's going to rely on themselves and the full use of their computer or their machine before they rely on a virtual assistant for a lot of tasks. There's a hopeful outlook. There could always be further improvements, and the way that technology is developing right now at such an incredibly rapid rate, if there's a breakthrough in another area, another way of modeling, we talked about how, for example, there was the branching model where there were different things being worked on in parallel, something along those lines, then we can see strides and improvements. For now, I'm not super impressed, and I hope to see a lot of the data issues that I talked about being addressed by different groups using these technologies as time goes on. So that's it. Those are all my thoughts. Really happy to be able to sit down and talk over this with you. I want to know whether you agree. So essentially, whether you happen to use voice recognition, speech recognition, and virtual assistants all the time. Like maybe that's something you rely on every day and you have a use for it that I haven't thought of or haven't come across. Or maybe if you are from another country that's not the United States and you have an accent and you try to address it, whether that works. I also am really curious to know how speech recognition works in other languages. So for example, if you're speaking French, English, Portuguese, Hindi, whatever it may be, how well does it do in those languages and the different regional dialects that you get in those languages? And as always, I appreciate you watching. Stay tuned for a new video once a week for the foreseeable future. And I hope to continue exploring these types of topics with you guys. Have a good one. Bye.